Here we are, Power Focus Area 10, our last one of the year. This will be Objective 1, talking about forces and energy in terms of fields. If you remember, a force is simply a push or a pull on an object, and what they can do is change an object's motion. So they can make them move faster, slower, or just change direction, and that's what forces are able to do. Press pause as you put this in your note guide. This is a multiple choice, so press pause while you think of your answer on your Pear Deck. And hopefully you picked a push or a pull. And remember, it can cause a change in motion. Stop, turn, or speed up. So the biggest thing we talked about, one of the two big things from this focus area was contact forces versus non-contact. And if you remember, the word contact means touch. So contact forces are forces between objects that are touching. Here's a bunch of example: a crash, a collision, physically pulling stuff or pushing stuff, and even tension in a rope because it has to be touched in order to work. Friction is a big one. Friction is a contact force between any two objects that touch, and it's trying to stop motion or oppose motion. Friction between the tire and the ground is what allows it to move forward. So without friction, like when there's ice, it's very hard to do that because the force is much weaker. Press pause as you put this into your notes. So if contact forces are forces between touching objects, non-contact forces are forces between objects that don't touch. Think gravity. The apple falls from the tree. Well, it's not touching the ground, but it's still pulled. So gravity is a non-contact force. We talked about magnets. We did that little mini magnet lab. Magnets don't have to touch to impact each other, as well as electricity. When you remember, we didn't touch the machine, we got near it, and it would shock us because it's a non-contact force. So fill out this little table in your notes. Press pause if you need to. So the three I mentioned were electric force. Remember, electricity means charged. So opposite charges, a positive and a negative, opposites attract. Same charges, two negatives or two positives, repel or push apart. Just like our magnets, when we put the two norths, the same ends, they pushed apart. When we put a north near a south, they pulled together because opposites always attract. Go ahead, add this to your notes. Press pause if needed. Some practice questions on your Pear Deck. Is pushing a desk contact or non-contact? Pause as you answer. Well, to push it, you have to touch, and touch means contact. So contact is correct. Notice in those first two pictures, go ahead, pause before I give the answer. They don't have to touch to interact, so it's non-contact for magnets. All right. We talked about vectors in Power Focus Area 5 that we're doing now in our finals, and a vector shows two things, and both of them are indicated by a line and an arrow. So notice I have 1, 2, 3 different vectors. The arrows tell us which direction the force is moving. So all of these forces are moving to the right. The length of the line tells us how strong the force is. So vector 1 and 2 are the same strength because the lines are the same distance. But vector 3 is much stronger because it has a bigger line. So magnitude or strength is the length of the line, and then the direction is simply the arrows. Go ahead, add that to your notes. Press pause if you need to. Press pause while you answer this on your Pear Deck. And as we just said, vectors show us direction by the arrow and strength or magnitude by the length of the line. So we're going to have you draw a strong vector in red on this Pear Deck and a weak one in blue. The arrow, as long as you have an arrow, it doesn't matter which direction it is. And since the red vector is stronger, your red line should be longer than your blue. And hopefully you are good to go for Objective 1 now.